Hello viewers, welcome back to another section of my multivariable calculus tutorials. In this video, we are going to solve a problem in double integrals in polar coordinates. So, I have integral from negative 2 to 2, then integral from negative square root of 4 minus s squared to positive square root of 4 minus s squared of the function s squared plus y squared plus 3 dy dx. This means that we're going to solve the y first, that is the inner integral, before the outer. To convert this to the polar coordinate, you ask yourself, what do I need in the polar coordinates? So you realize that in the polar coordinates, you need r and you need what? Theta, right? So these are the two important parameters we need in the polar coordinates. So what you are going to do is, we are going to see the limits and convert them to the polar coordinate limits. So since this is my inner function, that is, I'm integrating with respect to y first, you realize that y goes in for this limit and x goes in for the outer limit here. So from that, we are going to get y to be greater than or equal to negative of square root of s squared of 4 minus s squared less than or equal to square root of 4 minus s squared, like this. Then you're going to get x to be greater than or less than negative 2 less than or equal to 2. This is in Cartesian. So what we are going to do is, we are going to make a slight sketch of this. So I'm going to get y, and I'm going to get my x here. So realize that x is from negative 2 to 2. So I have, let's say, negative 2 here, then 2 here. So I'm having x like this way. Then this is a function. So this is a curve, and it has negative parts and what? Positive parts. So we can draw it nicely here. We draw it out nicely here. With this sketch, you can realize that our radius is going to be from origin towards 2. So therefore, our radius is 0 less than or equal to r less than or equal to 2. The next thing we are going to show is to find or convert this to the polar form, or we need to take or get rid of any x and y from our function. Everything should be in r and theta, right? So how do we do that? Now, to compute this one here as I have here, since I have my radius, the next thing I want is what? My theta, right? So since I have a circle, complete circle, I'm only interested in the whole total revolution. So I'm going to get 0 less than or equal to theta less than or equal to what? 2 pi as the limit for the theta. So the next thing I'm going to do is, I'm going to have my limits. Always the theta takes the outer limit, so 0, 2 pi here, then integral, then the inner is the r, that is 0 to 2. Now if you have s squared plus y squared, you know its equivalent is r squared, right? I'm going to have r squared plus 3, then everything r dr d theta. So this is a constant term, that is the a in polar coordinates is given as r dr d what? D theta. So once you have this, the next thing I'm going to do is, I'm going to go straight away to simplify what I have here. So integral 0 to 2 pi 0 to 2 of r cubed plus 3r, right? Dr d theta. I'm going to integrate first with respect to r, then second with respect to theta. So with respect to r, I'm going to get integral 0 to 2 pi r4 over 4 plus what? 3 over 2 r squared. Then I'll have 0 to 2 here, d theta, right? This is simple computation. Here when I put 0 in, everything will be 0, so I'm going to put 2 there. So 0 to 2 pi, then I'm going to get 2 to the power 4 is 16 over 4 plus 3 over 2 multiplying 4 d theta, right? Now this is going to give me 4, this is going to give me what? 6. So integral 0 to 2 pi of 10 d theta, right? So once I get this, I can see that this is the same as 10 theta from 0 to 2 pi. Then this is going to give me 10 multiplying 2 pi minus 10 multiplying what? 0. So I'm going to get 20 pi as my final solution. So this is how to compute a simple double integral in the polar coordinates, given the upper and lower limits in the Cartesian form. We are interested in the r and the theta. You take your r as the radius or the maximum this circle will go. That is from 2. Radius is magnitude, so we are interested in the magnitude. So 0 to 2. Then your theta, since it forms a complete circle, 0 to 2 pi. You then convert everything you have here to the polar form. Thank you for watching this video. Don't forget to like, you subscribe, and you share.